Welcome to the Mathematics MI channel. In this video, I am going to generalize the integral from 0 to 1 natural log raised to the 2n of x over 1 plus x square dx. Well, how to begin? Okay, first I'm going to take our integral is equal to I, and then we know this is equal to integral from 0 to 1. Now here natural log raised to the 2n power of x times 1 over 1 plus x square. Now instead of 1 over 1 plus x square, we can use infinite sum. So we can write here infinite sum k is equal 0 to infinity minus 1 to the k times x to the 2k dx. Now we can switch the integral sign and sigma notation, so we can write sum of k is equal 0 to infinity, here minus 1 to the k, so minus 1 to the k, integral from 0 to 1, natural log raised to the 2n power of x times x to the 2k times dx. Okay, then we can take this integral is equal to j, and now we are going to evaluate the j. So j is equal to integral from 0 to 1 x to the 2k times natural log of x raised to the 2n power dx. Okay, now we can use a substitution. So if we take u is equal to minus natural log of x, then we can isolate the natural log of x. So natural log of x is equal to minus u, then we can isolate the x. So x is equal to minus e to the minus u. Here plus x is equal to e to the minus u. Then we can differentiate. So du is equal to minus 1 over x times dx. Then we can isolate the dx is equal to here minus sign, so minus x we know, e to the minus u times du. Well, now we can plug in here, so we can write here. Now we should change the limit, upper boundary and lower boundary. So we know lower bound when x approaches to 0, u approaches to, when x approaches to 0, we know u approaches to minus infinity, so infinity. When x approaches to 1, u approaches to 0. Now here x is equal to e to the minus u, so e to the minus u raised to the 2k power times natural log of x, we know minus u, so minus u raised to the 2n power, and dx is equal to minus e to the minus u du. Okay, then we can change the lower limit and upper limit. So here 0 to infinity, when we change the limit, this minus get cancelled, and here we have e to the minus u raised to the 2k power, here e to the minus u, we know this minus get cancelled, and we can simplify this. So e to the minus u raised to the 2k plus 1, so we can write the minus u times 2k plus 1 times, now here minus 1 to the 2n, we know 2n is always even, so minus 1 is equal to minus 1 to the 2n is equal to plus 1. So here we have u to the 2n power times du. Okay, then to evaluate this integral, again we can take a substitution. So if we take t is equal to u times 2k plus 1, then differentiate. So dt is equal to 2k plus 1 times du. Okay, then again we can substitute here. So integral from limit also 0 to infinity. Now e to the minus u times 2k plus 1, we know minus t, so minus t times now u we know t over 2k plus 1, so t raised to the 2n power over 2k plus 1 raised to the 2n power times du we know dt over 2k plus 1. Okay, then we can simplify. J is equal to, here 2k plus 1 raised to the 2n, here 2k plus 1, so we can take outside of the integral, so we can write 1 over 2k plus 1 raised to the 2n plus 1 power times integral from 0 to infinity e to the minus t times t to the 2n times dt. Now we know this integral is equal to gamma of 2n plus 1, and this is equal to 2n factorial. So we can write j is equal to 2n factorial over 2k plus 1 raised to the 2n plus 1. So we can write now our main integral I is equal to here k is equal 0 to infinity minus 1 to the k times now here j is equal to 2n factorial over 2k plus 1 raised to the 2n plus 1 power. Well, then we know here 2n factorial we can take outside of the integral sign, so we can write 2n factorial infinite sum k is equal 0 to infinity minus 1 to the k power over 2k plus 1 raised to the 2n plus 1. Okay, then this is familiar with us because we know this is Dirichlet beta function. This is not simple beta function or Euler's beta function. This is Dirichlet beta function. So this is equal to beta of 2n plus 1. As I remember, we used this function in a previous video. Okay, then now we can write I is equal to 2n factorial times beta of 2n plus 1. Okay, then this is the interesting thing because we know beta of 2n plus 1 is equal to minus 1 to the n times e, here 2n, here e is Euler's number. Don't misunderstand, this is not Euler's number e, this is Euler number, and also we call secant number and also call z numbers. So here e to n times pi raised to the 2n plus 1 power over 4 raised to the n plus 1 power times 2n factorial. Okay, this is famous relation between Euler number and Dirichlet beta function. So now we know 2n factorial get cancelled and we have minus 1 to the n times e 2n times pi raised to the 2n plus 1 power over 4 raised to the n plus 1 power, and here n is a positive integer, so we can evaluate any integral using this identity. Okay, we generalize the formula. If you like this video and my other videos, please subscribe this channel. Thank you for watching.